Hey people, Frank Cement here, working on Scorpion today. It's going to be part 2 of making the tracks. This part I'm going to maybe test it, try to find the weak spots in the design. That way I could improve it and producing all the rest of the tracks. I don't know how many. Probably tell you at the end of this video how much plates I have to make. So take a look at the track, see what I got right now. A little more in depth on how I designed the track plates. As you can see, I used the quarter round stock for the cleats as put it in an I shape or a double pitchfork. One of the two. The round stock only comes halfway on the plates where the tires ride on, and then a single piece through the center. Same thing with the other side of the fork. Only covers half of the plate that the tire rides on. I see a weakness there, and I see a weakness where the bolts are. Get into that in a minute. Side profile. You notice the round stock is angled up because this plate is on a different height than this. It's actually stacked on top. So when I put the round stock on the center plate, it's lower, so when I attach it to the plate where the tires roll on, it's going to be angled up. It's kind of what I wanted. For that reason, when the tires rolling on something and you're putting pressure on there, you notice the other end's wanting to spring up. I'm thinking it's going to want to stay on the tire instead of it wanting to move away from the tire. It'll want to lift up towards the tire. It'll keep the tracks centered on the wheels. If you keep the plate pushing against both tires, the guide is going to stay in its slot. That way, if it goes the other way, the guide's going to come out of its slot and the track's going to jam up. To get the chains onto the plates, I welded the bolt into place, and if you notice, there's 2 slots on the side. That's for the chain to move around. I notice when the chain's on it, the chain doesn't pass the flat stock, so I got to make clearance for the next link to move around. I'm going to have to do that to the washers too. I'm going to weld the washers onto the chain every other link. That way I don't have to worry about the chain sliding on the bolt. Another chance for it to jam up in the sprocket or on the track system. I'm going to have to notch out a little spot on here and on here. That way the chain doesn't bind up. I noticed playing with it, it wants to move up on the top half, and then it won't want to turn. So just making a little groove is going to solve that problem, and welding it onto the chain, probably just tack welding it here, here, will hold it in place good enough to keep it from moving around. It'll move around a little bit because these washers got a big hole in the center, but I'm sure when I make the sprocket I'll make it sloppy, that way it doesn't be a big problem. Okay, the track plates where the tire rides on is 2 inches wide. Tires I'm using is about 1.5 inches rolling surface for the contact patch. There's going to be a little gap in between the plates when you bolt them together. Probably make a little but that's okay. It's a tank. Tanks usually make that noise from the track, so I ain't gonna mind. I think it'll sound cool. Should roll over somewhat quiet because the tread on the tire is rubber. These things, track guides, pretty much 90 degrees from the plate, welded on both sides. And when we come back, I'll do a couple tests, show you how strong these things are. Okay, I'm all set up to do a couple tests, show you how strong these things are. I'll set the camera down, see if I can balance it on the ground, and do the tests. That way you get a clear view on what the track's doing. I'll set the plate on the wood on the tippy tip. See how strong the whole plate is. I'm going to do that by standing on it. See if it flexes. I'm not feeling it flex, but I'll watch the video and see how it comes out. I'll flip it over, do the same thing. That track guide's on there, it's not even done. Okay, for the next test I'm going to do a pressure test with a hydraulic press and a gauge, and to see what kind of pressure it's going to take to bend it. Nah, I'm going to drop a brick on it. That's a big brick too. See if I can break this sucker. A little higher. Oh, starting to bend. Starting to bend right there. Evidently that's going to be a weak spot, so see if I can bend it the other way. I'll drop it right on there. Bent it back. Okay. You see, it's probably straight for the most part. It's a pretty heavy brick. Say it's a good 5 pounds, if not 10 pounds. It's one of the bricks for foundations. I dropped it from my knee down onto it, so it's about 2-foot drop. Okay, when I come back I'll have the track plates bolted to the chain with the washers welded onto it. This chain is a test chain. The chain I'll be using is I don't know if I get a picture of it. Well, anyways, I'll just read it. It's a straight link chain. Number 2, working load limit is 545 pounds. So I'm going to have 2 of these on each track, so working load limit should be well over 1,000 pounds. I bought this at Home Depot. That's 40 feet. That's enough to do 1 track. I figure I'll cut it in half, 20 feet, and then count the lengths, 18 feet, to figure out how many plates I need to make. But yeah, this is like 40 bucks at Home Depot for 40 feet of this. Okay, I'll be back. Okay, I'm back. Got done making a jig for welding the washers on. I'll show it to you. This bar is pretty much what I'm making all the jigs on. This section here is for making my other set of tracks. My other set of tracks is for a more heavy duty tank, maybe for a motorcycle V-twin. I won't show you that right now. So far, everything that pertains to this tank, this here, it's hollow. If you notice, you stick the round quarter stock inside there and bend it, pull it out, and bend it again, which is making the horseshoe on the back side of the track. Makes that piece. Now to weld the washers on to the chain, I made a little jig here. Best thing to make the jigs out of is the same material that you're making the parts out of. It's basically a length cut in half. One on this side I welded to the plate. Welded that one to the plate. Here we go again. Gone. There it is. So I got 2 of these welded onto the angle iron. Then I took a bolt that's bolting the chain to the track, and I welded it onto the angle iron, and I used a nut for a spacer, which is that right there. And then I welded a washer on there. Now, to weld the washer onto the track, oh, need a washer. Set the washer on, set the link in between. Notice the links are centering the washer. The washer that's welded to the bolt, all I gotta do is take my 2 fingers side by side to center that. If I need to, run a nut down, and that holds the link into place. Then all I gotta do is tack, 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 and the washer's on. These slots here is for the chain to fall down. You notice this one and this one are on an angle. It's actually pulling the links tight. and that helps with all the spacing also. I already did a set. Proven to be pretty easy to do. 3 little tack welds on that side and 3 little tack welds on that side. Seems to be pretty strong. I don't think it'll break off. And they're right in the center, and I notched the washers on each side. And the binding problem is solved too, so that's how I'm going to do the chain. Now I just got to remember not to weld the washer on this side and the next one on the other side. I already did that. It's proved to be pretty easy to fix. Just cut the weld here and here and flip the chain over and re-weld it. Pretty easy to fix, thank God. That's how I made the jig for that. I'll be making more jigs to make the other parts. The best thing to do to make the parts all the same is to jig it up. For it to be an effective method, everything's going to be exactly the same, which is what I want and which is what it needs to be for proper spacing in between the tracks and for the parts to fit together right. I'm counting on that, so let's see what's next. Will be I gotta roll out the chain, and I gotta figure out how much material I need and figure out how many links I need to make plates for, and I could do the math now that I know what I need and how much material. So that'll be next. Bye. Okay, I'm back. I got done crunching the numbers. Numbers come out to be 14 feet of chain, 2 pieces of chain, 65 track plates per side, so that's 130 track plates total for both tracks. Wow. I wrote it all down, I calculated everything. You want to know what everything is, I'll scan it and put it at the end of the video. That includes all the hardware, the flat stock steel, and the round steel stock that's needed to make. Is that 14 feet per side? Okay. Let me show you the chassis, how I'm setting up the chassis. See, it's going to have a single piston Briggs in there. I can't fit a twin in there because I didn't have one when I was making the frame. These bars are in the way. Maybe later on I'll cut these bars out after I get the suspension in and see if I can fit a twin in there. That's much later. I want to have some fun with it. So it's set up for a single piston. Maybe a 10 or a 15 horse. I got a 15 horse, but it needs repaired. I got to weld the housing together. Dashboard, it's going to be a key start. Key switch is going to go there. Headlight switch, electrical gauge, and the choke. That's my dashboard. Gas tank's going to go right here. Battery's going to go in the back. This section here is going to be the drive section. See, between these two are the bearings. The pulley to drive it is going to go right here, and then the brake over here, because this part is the transmission holder and the pulley is somewhere around here. To drive it by a belt, it's going to be a jack shaft coming out, and then the sprocket's going to be here. The tracks are going to be on this side of the frame. Right there is where you're going to put your feet. This bumper will probably come off. It's pissing me off. It's getting in the way of dragging it around. Let's see. Same thing on this side. Put your feet there. Bearing the shaft. Sprocket will be here driving the track. Let's see. Suspension. The center point will be right here. Gonna have a bar coming down. Dual wheels. 4 wheels all together. Then the front one is going to come down pointing towards the front for more stability, and then 4 wheels on that roller. I'm going to call them rollers, and then you got the suspension arm. Then the shocks will be mounted somewhere there. I got to make all that, all the suspension brackets I got to make still. I think that's it. Oh, the engine, it's going to come down, it's going to have a centrifugal clutch. The belt's going to go in between there to, this is the jack shaft holder to the top of the transmission. And then if ever I need to change the transmission or put a different kind in there, all I got to do is cut out these brackets, make new brackets, and mount a new transmission in there. Steering system going to be controlled by these 2 rods all the way this way. That's when the tracks are going to be driven. It's going to be in 3 stages. This is the first stage, which would be driving. The second stage would be halfway, which will disengage the clutch only, and then the rest of the way will be applying the brake when needed. Both of these rods move independently. You can only actuate 1 rod at a time. They'll be spring loaded, so when you're pulling on it and you let go, it's going to go back to the drive stage. And then of course the rods come to a pivot point. From this pivot point, it's going to be working the linkage down for the clutch and the brake. This side is actually going to drive the other side, if you think about it, because when you turn this way, you're moving the rod on this side to unlock or to disengage this track and to brake. Kind of works backwards. That's the gist of how I'm going to do it. So if you like the video, rate it, comment, subscribe. Thanks, man. Bye.